Okay, okay. So the next question that we got on the menu today is about the human body and the way that blood moves through the human body. Okay, so the question is asking blood is flowing through an artery of radius 2 millimeters at a rate of 40 centimeters per second. Determine the flow rate and the volume that passes through the artery in a period of 30 seconds. Okay, so uh, let's identify the numbers of interest out of this question, because all this other stuff, to contextualize it inside a human body is not necessary. We're just trying to get the numbers, get the proper calculations, and then get our final answer. And then once we get our final answer, recontextualize that in terms of what's going on in the question originally. Okay, so we got blood flowing through the artery, radius of 2 meters. So radius is 2 millimeters, and this is the it's kind of like the opening that the thing is flowing through. Opening that fluid is flowing through. Okay, now blood is flowing at a rate of 40 centimeters per second. Yeah, so I guess linear flow rate, let's call that I guess they had it as V. We can keep it as that. V is equal to 40 centimeters centimeters per second, and this is like linear flow rate. And let's convert these SI prefixes into coefficients, just so our units will always line up. So this will be 2 times 10 to the negative 3 meters, and V will be 40 times 10 to the negative 2 meters per second. Okay, so we want the volumetric flow rate. Wants volumetric flow rate as well as total or volume flowed. I guess that's probably the best way to describe it. The volume flowed in 30 seconds. In 30 seconds. Okay, so let's get the volumetric flow rate. So we're given the radius of the opening and the linear velocity, which is like the length of stuff that goes through. But we need to just get the volumetric stuff. We have to multiply that by the area of the opening that is flowing through. And we're going to assume that the flow rate is always constant. Yeah, because I guess in the human body, because your heart is like bum 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 bum, like it sends a flow and like in pulses, like it's not always going to be 40, it's going to like vary around. But for the purposes of this question, we can just assume that the heart is more like a constant pump that doesn't like fluctuate the flow rate. Yeah, and that's a nice approximation that we can use. So we want our volumetric flow rate. I wonder what they use for the variable here. They used Q for volumetric flow rate. Capital Q. So we can use the same. The variable that you use is not particularly important. What's important is that you you keep it aligned in your head. You're like, don't all of a sudden think that Q now means charge. Okay, so we know that our volumetric flow rate is going to be equal to the area of our opening multiplied by the linear flow rate. Area of opening, and this is linear flow rate. Okay, now it says it has a radius of 2 millimeters, so we can only really assume that it's going to be like perfectly circular, because otherwise it would be impossible to calculate the area without additional information. So it has to be a circle if we're only given the radius. So the area of a circle is going to be equals pi r squared multiplied by the linear flow rate. And let's sub in the numbers. So we know that our r value is 2 millimeters. So that's 2 times 10 to the negative 3 meters squared. Multiply that by the linear flow rate, which is 40 times 10 to the negative 2 meters per second. Okay, now if we look at our units, you can see that we have meters squared times meters per second. So our final unit is going to be meters cubed per second, which is perfect. That's the volumetric flow rate, the amount of volume. That's the meters cubed per second. Okay, that's great. And for the value of this, let's send it through the calculator and figure it out. So we got pi multiplied by, and then in brackets, 2 times 10 to the power of negative 3 meters. But we got to square that whole thing. Square it, and then multiply by 40, multiply by 10 to the power of negative 2 for the centimeters. And what do we get from that? We get 5.0265 times 10 to the negative 6. And all of our units, we converted them into base SI, so it should be meters cubed or cubic meters per second. And that is a very small number, but also keep in mind, a cubic meter is quite massive. Like so we would expect a very small number of cubic meters. A cubic meter, that's like, you could fit probably 1 or 2 people inside of a cubic meter. 1 or 2 small people. Okay, so this will be our volumetric flow rate. It will be that value. Is that the same that they calculated? 5.0265. I guess without the rounding, it's good. Now, if we multiply the total volume flowed in 30 seconds, well, we just multiply our volumetric flow rate with the time. So I guess the volume, oops, let's not use that curly V, let's use capital V for volume, or let's just say vol of blood is going to be Q multiplied by the time flowed, QT. Ain't that a cute little thing? What a cutie. Ha ha ha. Okay, so to do the math, let's do 5.0265 times 10 to the negative 6 meters cubed per second. You know, this is kind of like asking, if you're driving 70 miles per hour, how long, and you drive for 1 hour, how far do you go? 70, buddy. So it's kind of like that. So we multiply this by, how long does it ask for? 30 seconds. So if every second we're flowing this much, multiply that by 30 to get how much we'll get in 30 seconds. So 30 seconds. So pull out the calculator. Still got the old value of 5.026 times 10 to the negative 6. Okay, multiply that by 30. And what do we get? Our total volume is 1.508. I'm rounding up because it's actually 1.5079, but I'm going to round up to 508, multiplied by 10 to the negative 4 meters cubic meters, actually not per seconds anymore, because the seconds down here and the seconds up here neutralize each other, so they got to be just cubic meters. And that's still a very small amount of cubic meters, but considering how massive a cubic meter is, that makes a lot of sense that you'll still have a small number after going for 30 seconds. Okay, and hopefully we got the same calculation here, 1.507. We'd accept that because it's likely just a rounding error with the calculator, but otherwise the above solution is good. So the key thing that you want to pay attention to is the units. The units can tell you a lot about what you should expect in the question. Okay.